Welcome to activity 4.1, measuring forces. So our learning target for today is we're going to determine how forces are measured and how strong a force is in a spring. So what you see on the video is a spring scale. And because you must have missed a lab for some reason, you're doing the alternative via the video. So what I'm going to do is I'm going to take 4 washers, and here is a washer. And right here it is. So what I'm going to do is I have 4 washers, and you were supposed to design an experiment to see what kind of forces act on the springs of the spring scale. So here's the top part of the spring scale. I have it zoomed in right now so you can see the measurements on it. So what I'm going to do is I'm going to put this ring or this washer on the bottom of the scale, and what we're going to do is we're going to measure how far the spring scale comes down. So when I put it on there, and I'm putting it on there gently, we can see that it came down 1 line. Now if we look at those lines, there's how many lines in between the 0 and the 2? It's 1, 2, 3, 4, 5. So what does that tell you about the scale here? So go ahead and figure that out. What would it be? Well, what is 2 divided by 5 going to be? Well, let's add a 0 to it, 20. So if we took 20 and divided it by 5, what do we get? 4. Now let's move it back, the decimal back over. So each line is 0.4. So the one washer stretched the spring 0.4 newtons. And it's hard to see the end, it's right above, it's kind of on the top of the video. So now I'm going to take a second washer and I'm going to place it on here. So now what it do? Well, it moved down to the second line. So if the first one was 0.4, the second one's going to be 0.8. So record this data. Now I'm going to add a third washer to it. And what's the new reading? It went down to the third line. So now it's at, well, if we had 0.4, 0.8, now it's 1.2. And I'm going to add a fourth washer to it. And now it moved down to that next line, so it was 1.2, now it's 1.6. So what you need to do now is open up, and hopefully you've already done this, but open up the lab sheet in Google Classroom and go ahead and complete everything you need to do. You need to figure out how you're going to record this data, and you're going to need to record that data on that sheet that you have. Then you need to consider the 4 questions. Does the spring get stretched by the same amount each time, and the same mass is hung from it? If so, answer that question, yes, no. But if you notice on a sheet, you have to write a little mini CER. So what's your claim? So yes, every time I put a mass on it, it gets stretched by the same amount, or no. But again, it can't just be yes or no. So make a claim. What's your evidence to back it up? And what's your reasoning? And your reasoning doesn't have to include scientific principles, but what's your reasoning? Why? The second question, does the spring return to its original shape each time after the mass hanging from it is removed? So we didn't necessarily do that, but I'm going to remove all of the stuff from it. Now, did it move? Did it return back to its original shape? Is it back where we started? You can always rewind the video and check. But based on what you see in this video, go ahead, make a claim, back it up with evidence, and then link the evidence back to the claim via reasoning. Number 3, what is the relation between the amount of spring gets stretched and the size of the mass hanging from it? So based on what you see in the video, go ahead, make a claim, back it up with evidence, and link the evidence back to the claim with reasoning. And then the 4th question to consider, how can you tell the size of a mass by the amount it makes the spring get stretched? So think about everything we've done, use the data, make a claim, back it up with evidence, and use reasoning to link the evidence back to the claim. So go ahead and complete the activity sheet 4.1 in Google Classroom, or if you can't get access to Google Classroom, go ahead and complete this activity 4.1 in the book. If you have any questions, make sure you ask. Thanks. Bye.